Hello everyone. Hi, welcome to askIITians. I am Manish Nihalani, your mathematics mentor. So we would be learning basically हम लोग triangles chapter continue करने वाले हैं. Welcome to askIITians. This is lecture number 3 of triangles. So let's quickly continue. In the previous classes हमने देखा था कि triangles chapter कितना important है and what is the board weightage of this chapter. हमने देखा था लास्ट क्लास में कि इस चैप्टर की बोर्ड वेटेज इज 9 marks. मतलब ये चैप्टर बहुत ही ज्यादा इंपॉर्टेंट है फ्रॉम बोर्ड्स पर्सपेक्टिव बिकॉज 9 marks के क्वेश्चंस आते हैं इसमें से विथ ऑप्शन BPT. And now we'll be talking about now we would be talking about today. So these are the topics which we are going to cover today. These are the topics which we will be covering today, right? So right, I hope you all are excited. So let's begin without wasting any time, right? So yeah, these are the topics. SSS similarity we will be covering. We would be talking about SAS similarity. What is that SAS similarity test and all of that. And we would also be talking about relation between areas of two similar triangles. Right. So let's quickly move forward. So what is SSS similarity? What do we mean by SSS? SSS means side, side, side similarity, which means basically if in a triangle we have three sides, we would say the SSS similarity criterion states that if the three sides of a triangle are respectively proportional to the three sides of the another, then the true triangles true then the two triangles are basically similar. So if you just look at the figures here, so we have triangle ABC, right, and we have a triangle PQR. Now these single lines means what? These single lines means in this triangles AB is equal to PQ, or we can also say that length of AB is equal to length of PQ. All right. Or we could also say in other sense that length of AB upon length of PQ are in same proportion with length of BC and length of QR. And also they are in same proportion with length of AC and length of PR. So if these conditions are satisfied, these three conditions are satisfied, if this is the case, when all the three sides of a triangle of one triangle are in proportion, are proportional to the other three sides of the another triangle, in that case we say that the two triangles are similar, and they are similar by SSS test. So here triangle ABC is similar to triangle PQR by SSS test, that is by side 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 test. Right, very simple, pretty simple, right? Now one more important thing to be noted here, that the lengths of the corresponding sides should be in proportion. They need not be equal. The lengths of the corresponding sides can be in proportion, need not be equal. So I hope that is clear. That would be more clear with the help of this example. Okay, so it says determine if the following triangles are similar. If so, explain why and write the similarity statement. So here we are talking about triangle, again triangle ABC, and we have triangle DEF. Okay. So we just want to know that are these triangles similar? So we are given the lengths of all the sides of these triangles, right? We have length of AB, BC, AC. We have length of DE, EF, DF, right? So if we have the lengths of all the sides, why not compare them and take the proportions and check whether they are in same proportion or not. So let's do this. So we would say take the longest side in triangle ABC. Which is the longest side in triangle ABC? Is that AB, BC or AC? So we can clearly see that it is BC. right? So we would say BC. Now take the longest side in DEF. How much is it? It is DF, right? BC by DF. Now, what is the length of BC given to us as? It is 28. What is the length of DF? It is 20. So we would say the ratio is somewhat 4 sevens are and 4 fives are 7 by 5, right? Take the middle side. Now the middle side after 28 is 21. So we'll say this is AB, and after 20 in this we have EF, right? So AB and EF. So we have 21 divided by 15, right? So we'll say 3 sevens are and 3 fives are. So we would say, now let's check the last side, the shortest side. The shortest side is AC, right? And in this the shortest side is DE. So AC is 14 and DE is 10. So if you just use the table of 2, you will get, so we can clearly see that BC by DF is equal to AB by EF is equal to AC by DE. That is, we can conclude therefore the sides are in proportion, right? The sides are in proportion. So in that case we would say that the triangles are similar by SSS test. This is the similarity statement. So we would say the triangles are similar. Now you should carefully name those triangles. So you have to be very careful in naming. Look how we will be carefully naming those triangles. We will not say ABCE and DEF. In this case we can clearly see that BC by DF. So with BC we get to see DF, right? So it should be ABC and DFE, right? So triangle ABC is similar to triangle DFE because AB is also similar to EF. So this is AB and this is your FE or EF. This is how it works. So you have to very carefully in proper order you have to name the triangles so that it should be easy to understand for everyone, and it should be eye pleasing as well, right? So every time we like eye pleasing things which are properly, so that we can get the corresponding sides and all of that, right? So this is how we name it. So yeah, this is the solution of it, and you all can clearly see that they are similar by SSS test. Okay, so now let's understand next test. We have SAS similarity test. What is SAS here? So we would say if two sides in one triangle are proportional to two sides in another triangle, right, and the included angle in both are congruent. Now what do we mean by included angle? This is a very important word in this statement, that is the included angle, because if two sides in one triangle are proportional to the two sides in another, then an included angle, so two sides in one triangle, which means here your AB and DE could be in same proportion with AC and DF, right? So this is your AB and DE, this is your AC and DF. If these are in same proportion and measure angle BAC is equal to measurement of angle EDF, then in that case we would say that these two triangles are similar, or these two triangles are congruent by SAS test, right? Triangle BAC is similar to triangle EDF. This is how we would say. This is what we mean by SAS similarity test, right? So let's quickly check with this, and we have a question now. So we'd say determine if the following triangles are similar. If so, write the similarity theorem and the statement, right? So we have triangle DFE, wherein DF is side is given. So which is the biggest side here? We can see DE, and which is the biggest side here? We can see BC. So what is the ratio of them? 12 by 20, which is nothing but 3 by 5, right? Similarly, we can also check uh, the other side. Which is the other side? We have DF and we have AB. So DF is how much? 9, AB is 15. We also have this 3 by 5. So far things are pretty good. Now let's check about the angles. Now here we can see that we have the angle E as 45 degrees, which is measure angle DEF is 45 degrees. But we always need the included angle. That is, if you are given the two sides in same proportion, the angle should be included angle, like the one in triangle ABC side, right? The angle containing the two sides. So here we don't have that included angle as 45. So we would say that this is not the included angle. This is not the included angle. So in that case, we will say that these two triangles are not necessarily similar. If this angle D would have been 45, or if we would have somehow known that, okay, let's say that angle F is 90 degrees. If we would have known that, then we would have been able to find angle D and then comment on the similarity or comment on the similarity or something like that. But here we can't comment anything. So we would say, therefore, triangle ABC is not similar to triangle DEF with SAS test or any other test, because we just have the information about their sides. We don't have any information about their angle, and we don't even know the third side. How is it related? Right. So that is why we would say they are not similar. Right. Correct. The angle is not the included angle for both the triangles, right? Let's quickly move to next. So now we have relation between areas of two similar triangles. Now comes the interesting part, that is, the area if you have the area of both the triangles, how is the area of two triangles related to the sides of the triangles, right? This is what we need to understand. So we would say, let's start with two similar triangles first. It is given that the two triangles are similar. So we would say what we are given. Let's first draw two triangles, right? That is triangle ABC and triangle, maybe we can take DEF, right? So let's take triangle ABC. This is A, B, C. And then we have D, E, F, right? So let's see. So we are given that triangle ABC is similar to triangle DEF, right? So the ratio of area of both triangles is proportional. So in that case, we would say, what do we have to prove here? See, we have to prove that the ratio of areas, that is area of triangle ABC upon area of triangle DEF, is equal to square of the ratio of their corresponding sides. Square of their ratio of their corresponding sides. So corresponding sides always, how do we find? By the name itself. So we can say that since we have AB here, AB will be corresponding to DE, right? AB would be corresponding to DE. So we will in that case say this is equal to AB square by DE square. What is the other side? BC square by EF square, right? And the last one we have AC square by DF square, right? So this is how the two triangles are similar, and we have to prove this result, that if they are similar. So how do we prove? We would say, first make a construction. what constructions we will make. So we would say draw a line AL which is perpendicular to BC. Okay, so we are drawing AL perpendicular to BC. We are also drawing DM which is also perpendicular to BC. So don't say DM is this, DM is direct message. That is not your DM here. DM is just a line segment, right? So DM is perpendicular to EF here. Clear? So now let's start with the proof. So what we are given, first of all, that the two triangles are similar. So now we know one fantastic thing. When two triangles are similar, when two triangles are similar, then they are equiangular, which means they all have equal angles, right? All the three angles of one triangle are equal with the three angles of the other triangle, and they are corresponding sides, and their corresponding sides are proportional. Corresponding sides are proportional. So therefore, if triangle ABC is similar to triangle DEF, we can say that the corresponding sides are in proportion, that is AB by DE is equal to BC by EF is also equal to AC by DF. And also we can say that they all have same angles, that is angle A equal to angle D, angle B equal to angle E, and angle C equal to angle F. Right, this is what we know. Then now we would talk about the smaller triangles. So let's see now which are the smaller triangles. Now you can see that we have drawn a perpendicular AL and DM. Those two perpendiculars divide the bigger triangles into two smaller triangles, right? So we would be talking about them now. So now we would say in triangle ALB and triangle DME, right? Triangle ALB and DME, we know angle L equal to angle M equal to 90 degrees, right? The angles are 90 degrees. Also we have angle B equal to angle E from this equation 1, right? From equation 1. So we would say that triangle ALB is similar to triangle DME by which test? Absolutely correct. By AA test, by angle test, right? So we would say if the triangles are similar, then their ratios of sides are equal. That is AL by DM, AL by DM should be equal to AB by DE, AB by DE, right? Using CPCT, right? Using CPCT. Now, from this equation, that is equation 2 and equation 1, we would be able to interpret that all four ratios are equal, right? From 1 and 2, we can clearly say, so from this first equation, that is the sides and the angles one, and the second equation, from 1 and 2, we would be able to say that AB by DE equals BC by EF is equal to AC by DF and is also equal to AL by DM, right? AL by DM. This is how we basically say that all these four sides are equal, right? So now we would be talking about ratios of areas. So let's name this equation as equation 3. So let's come to area of triangle ABC and area of triangle DEF. So let's see. So in ABC, we have the base as BC and height as AL, right? So that would be half into BC into AL. And what would be the area of triangle DEF? It would be half into EF into DM. Half into EF into DM, right? So half gets cancelled. BC by EF, we would also be able to interpret that here we have BC by EF into AL by DM, right? But from equation 3, AL by DM is equal to BC by EF, as we can see. So that would be equal to BC square by EF square, right? We also can say that if this is equal to BC square by EF square, then it is also equal to AB square by DE square and is also equal to AC square by DF square, right? This is what was required to be proved, and we have similarly proved that the ratio of areas of two triangles is equal to the square of the ratio of squares of their sides, right? So this is how we prove the results, and using similarity of triangles, right? So we use the AAA similarity which we had learned in lecture 1. So this is very important to understand, and let's quickly have a go through it, right? We made a construction of altitudes and then we proved the triangles similar by AA test, and then we just got the result, right? So let's quickly understand this with a very simple example. So we have in triangle ABC, this is your triangle ABC and APQ, right? So we have AP as 5 centimeters. This is AP, which is 5. PB, which is 10, right? This is PB, which is just 10 centimeters. AQ is what we don't have. We have BC as 20, so the base is given to us as 20 centimeter. Now this arrows, you all can see that these arrows are basically, it signifies that the two line segments are parallel to each other. They are in same direction. Okay. So yeah, let's quickly move forward and with say triangle APB. We can see that angle A is 60° here. Okay. So we are interested in ratio of areas. So area of triangle ABC and area of triangle APQ. This is equal to ABC, which is the bigger triangle, right? It is the bigger triangle. So in that case, it should be AB square upon, and when you talk about APQ, it should be just AP square, right? AB square upon AP square. So AB is how much? AB would be 10 plus 5, which is 15. So 15 square, and AP would be 5. So it's just 5 square. So it's just 225 upon 25, which is just 9:1, right? So the ratio of this is 9:1 or just 9, right? So therefore, if the triangles are similar, we can clearly say that the ratios of areas is equal to ratios of squares of their sides, right? So let's quickly move to next question. It says triangle ABC is similar to triangle DEF. It is given to you that triangles are similar. Triangle ABC is similar to triangle DEF, and their areas are this and this. So we would be needing EF. We find BC. So you would say area of triangle ABC upon area of triangle DEF is equal to BC square by EF square. So we have the ratios of their area. So you would say this. Therefore, 64 by 121 is equal to BC square by 15.4 square. Therefore, from here we can say that BC would be equal to square root of 64 into, or 64 by 121 into 15.4, right? This will be outside the square. So here we have 8 by 11 into 15.4. So if we calculate this, we get the answer as, let's quickly try this. So we'll get 8 into 15.4 divided by 11. So this is just 11.2 centimeters, right? 11.2 centimeters. So this is like how we solve for areas, and we solve for SSS test and SAS test, the included angle test. So I hope you all had a good session and you all understand the triangles lecture number 3, and we will be solving, we would be understanding more and more interesting concepts in the next lecture. Till then, stay safe. Thank you very much and take care.